Hi, everyone, and welcome back to the AI Interconnect podcast. I'm your host, Lauren. Today, let's go to space with AI. On this show, we talk with founders and operators building real system in AI and technology, and we focus on what is actually changing inside industries. AI Interconnect is a platform to surface clear thinking from people who are building, not just commenting. And today, I'm joined by Gaurav Bajaj, co-founder and CTO of Little Place Labs. And Little Place Labs builds software that runs AI directly on satellites. So insights can be generated in orbit instead of waiting for data to come back to Earth. Gaurav, thanks for being here. Very, very happy to have you on the show.
Thanks for inviting me, Laurent, and I look forward to our conversation.
Wonderful. Okay, yeah, me too. Let's go to space. You mentioned in our pre-call that you started your career in banking and fintech. And today you're focused on deploying AI in space. That's not a common path. Girl, how did your background in banking and fintech eventually lead you to co-found Little Place Lab and focus to AI deployed in space?
No, great question, and I do get asked this question quite a bit, and it's surprising in a way. Why would somebody do that? I'm based in London, in the UK. I've been here for the past 18 years, and over so many years, I've fallen in love with the city. London is the place where when I came here, I established myself working in financial services, banking, fintech, in the technology side of things. And in the last decade, I really enjoyed my time. I did so many roles, played so many roles, worked with the really fantastic people in London, and I love the city. I love the weather. I love the British weather. Not a lot of people say that, but I do. And it's about, I believe, over a period of time, how your career grows, how your aspirations grow, and where you find yourself, doing things which you probably thought you would or you would not. So the way it worked for me, uh, I worked in banking, in consulting, in technology consulting, and over 5 years, I was really kind of saturated with myself and I wanted a good break. So in 2015, I took a uh, gap year and traveled the world around, uh, you know, in Southeast Asia, East Asia, and South America. And that opened my options to taking risks. And I realized that I don't need a salary on an ongoing basis. If I can live without a salary for 14, 15 months at a go, there's a lot more I can do if I, plan appropriately and figure out what I really want. So at that instance, when I came back from my world trip, I entered into the blockchain space, and that's essentially fintech. Not very far from what I was doing, but that got me traveling a lot, working for a American Silicon Valley company. I got really good exposure to how people take risks, move their lives. But 5 year down, I realized I'm hitting a glass ceiling in my career at an age, at a level of maturity. And I realized that to get to the next ladder, I need to go and fulfill my long old dream to get an MBA. So I went to Oxford. Luckily, I spent really good 2.5 years at the side business school doing my executive MBA program. And that's where the shift came. And it was amazing because I realized that I've got so many like-minded people who have big aspirations and dreams and want to do something, are trying to figure out what to do next. And Oxford, for me, gave an opportunity, gave that platform, had that support system around to try to explore what really means to you. I spent 18 years almost in fintech, and I realized this is not exactly what I want to do all my life. So I asked the child inside me, what would you do? And definitely space was big. So I remember getting into a 1 day space conference and asking everyone, hey, let's build rockets. Does the world need rockets to be built? And the answer was, no, it's too late. There are too many companies already solving that problem. Slowly venturing out in that space, we found a specific problem to work on. And I think we stuck to that. And that's how we essentially came up with Little Place Labs. That's also where I found my co-founder, Boscolai, and we have been working on this since more than 3.5, 4 years now. And I think it's an amazing journey.
Unbelievable. I love this. This is great and beautiful. One thing I I appreciate, and I jump directly on the place, and I appreciate about your positioning is the clarity around in orbit processing and reducing latency. When you explain Little Place Lab to someone outside the space industry, how do you describe what you actually do and who you help?
No, absolutely, and this is something that we try to practice every time. So we have something called cocktail pitches, but we do need to. I need to explain it to my 6-year-old son. So you sometimes have to really dumbify because he would not get that otherwise. So my 6-year-old knows that his dad works on building software on computers that go on satellites. So often in the night, we see satellites in the sky, not necessarily the International Space Station, but you can see satellites with naked eye these days. So what we do, satellites have sensors and cameras. Satellites watch Earth. They're capturing a lot of data and imagery. And what we do is we process that imagery on board the satellite and generate results and insights from them, in a matter of few minutes. Traditionally, the way it was done, you capture the imagery on the satellite, you bring the imagery down, and then you do a lot of processing. Back in the days, it used to be more visual processing by human analysts. Now, a lot of that is moving into machine learning as well and AI. And we are taking one step further. We don't want to run AI and machine learning on the ground because it takes way too long to do that, hours and sometimes even days, because of the way the satellites move around, how the data moves around, and there's a lot of data that gets generated in space. So our solution is to speed things up. We are working with our partner satellite operators to deploy our technology on the satellite itself. So that as soon as a satellite which is passing over, let's say, London or Paris, it captures the imagery and then immediately that gets processed. You look at the imagery, you're trying to figure out, how many cars are there, you're trying to figure out how many solar panels are there, or you're trying to find out some kind of pattern of light. You might be looking at change over a period of time. All of this can be done in a matter of minutes. And then we send down only a small amount of intelligence and insights to the ground. That can be done in a very short period of time. And that's what our focus is, to build the technology, to mature it, something that we're already doing. We have done several demonstrations, and we continue to make sure that it scales up to the level that it can start supporting a lot more customers.
Wonderful. I mean, I hope your 6 years old, understand all this. But this is
He
great. You must have a lot of fun
Yeah,
with
he
his
said,
dad.
I mean, they can be very smart. They probably won't understand all the terms, but definitely, it's about taking pictures from the sky, understanding what's in the picture. Is that a bird? Is that a ball? And then getting somebody know what's out there. So in the simple possible manner.
Yeah, that's beautiful. What type of mission or client benefits most when running AI directly in orbit?
No, great. So there are several use cases, and lately there's a lot of interest in putting data centers in space, which is essentially another category of use cases. So what we call is use cases. What can you really do by putting AI in space? Or let's say, why would you put AI in space? So in the space industry, there are terminologies like Earth observation, where there are cameras watching Earth, different kind of cameras, and they are collecting imagery, and you process that imagery because there are customers from both defense as well as commercial, non-government organizations need that information quickly. A really good typical example is about the spotting wildfires from satellites, which is, I think, one of the most understood and prominent use cases as well. And wildfires have caused billions and billions of dollars of damage across the world. It's a global problem, and we kind of need a global solution to tackle that. By number of estimates, if you can spot forest fires, wildfires early, you can contain them much easily. And the implication of that is and the dollar implication and the human life implication really becomes much less. So, and then you have, areas like disaster management, you have floods, and you have, hurricanes and post hurricanes, you want to monitor areas. That's where you need information in minutes and not in several hours and days. Because when you have precise information of an area, you can really action on that. And that's where we call actionable intelligence is what we aim to provide to customers. So, of course, beyond that, there's a lot of areas within defense and military purposes that we also work with because there is definitely an area of national security where the government organizations require that up to date and low latency, we call it low latency information. And of course, over a period of time space is getting crowded. There's a lot happening in space. You probably know, you probably may have seen there is news about satellites spying on other satellites as well. So it's in our national interest to make sure that we keep Europe protected, for example, from adversaries. And beyond that, with Gen AI these days, data center and the consumption and the requirement of data centers on the ground, the demand is huge. And there's a big drive to see, can space-based compute really provide a solution? I think there's a good use case here. The technology is there, but it's a matter of understanding how can we really make it work, and especially at a price point, at a place where it's more sustainable for the environment as well.
Yeah, I mean, as a matter of fact, Gaurav, will will we see through data center in space in the next decade?
Yeah, it's a good question, and I think I would just go back to everyone's perception and a definition of data center is can vary, right? So data centers can be small and they can be really huge. So if you talk about cloud by Amazon or Microsoft or Google, those data centers tend to be really huge. But you can also have medium and small data centers which are specific for specific use. Now there's a good claim that there's a lot of abundant solar power out there, which can be leveraged, and which is no doubt, that's the case. There are other technical challenges that need to be resolved, but a lot of companies and a lot of money is already flowing in those companies right now, which are building technologies to put data centers in space. So let's assume that if you can run operations either for some company or organization or running some kind of LLMs in orbit, that can be absolutely done today. It has been demonstrated in the last few months that you can run these in orbit. Even some of the high-end NVIDIA GPUs have been taken to orbit and shown that it can run. So the demos have already been done, and it's a matter of scaling that up. Scaling that up comes at a cost benefit analysis, whether can you deliver if you deploy so many NVIDIA GPUs or similar ones, can you really service customers and can you generate enough revenue? So I think this is where there's a lot of optimism out there. And I think that's completely possible. But I am absolutely sure within 10 years we will. Within 5 years, most likely we will. In the next 2 to 3 years is a very crucial time to see the how the market and the tech stacks. I think tech will work. It's more about how the market will require that need or not. Because we also understand a lot of us would agree we are somewhat in an AI bubble. So we just need to make sure when things normalize, the real technology, the real use cases will survive. But I'm quite optimistic that there is going to be enough compute available in space. What I'm not 100% sure is who's going to use it for exactly what purpose. Because we are already talking about building a base on the moon. And anything that goes beyond what we call low Earth orbit or medium Earth, LEO, LEO, MEO, and GEO, you will need compute because as we go farther from space, we need to put more compute out there. The speed of light is not fast enough for us to have real-time communication on the moon and definitely not on Mars. So I am quite optimistic about this trajectory over the next 10 years. Definitely.
Okay, I love it. Elon Musk think it's next month, but that's another point.
He's definitely more optimistic than a lot of people, I think.
Yeah.
And then what he says, I believe a number of things get done, maybe not all, but it definitely takes longer. So if he says 1 month, you probably assume 2, 3 years and then work something out.
Yeah. Well, what technical barrier need to be solved before that become viable?
Yeah. So there are a good few companies and very well-funded companies from Silicon Valley, and then there's a lot of effort even China is putting into putting these a lot of compute in orbit. The companies who make silicon chips and processors, they've also been very intrigued and are making what we call space-grade chips. So there are a set of problems right now. Every processor, every chip, AI chip, or that you take from NVIDIA, maybe from AMD, not everything is super ready to be deployed in space. There are certain chips are, let's say, radiation hardened or somewhat radiation hardened and ready for space. And when you want to place these chips beyond low Earth orbit, let's say beyond 400, beyond 500, 600 kilometers, then it needs more hardening. So in space, radiation is a big problem. A low Earth orbit somewhere is between 400 to 600, 700 kilometers. That's where most of the satellites are, and that's a crowded space. And because it's so close, you can get by using not extremely radiation hardened or not extremely expensive components. We call it COTS, commercial off the shelf components you can take and you can deploy. It can work decently well, but radiation is a big challenge. When you're building data centers, you need really big solar panels. There's a lot of technology in solar panels, space solar panels, that has been, of course, making improvements, and there's level of maturity on how solar panels are deployed, how efficient they are, and because of their size and up launching costs, that's a consideration. And my favorite one is, like, space is cold, but really, because when you have vacuum in space, vacuum is not a good conductor. You can't get rid of heat that's produced on the space data center. And that's one of the biggest problems to solve at this time. There's a lot of good work going on, so I think it'll be solved. I don't know to what level of efficiency, but it just means that it requires putting big radiators next to the solar panels, next to the chips, to get rid of the heat. And in space, the side that's facing the sun can be something like 150 degrees, and the side which is away from the sun can be minus 100 degrees Celsius. So the thermal variations in space are a nightmare, to be honest. And when we talk about all these missions, it's about how do you take care of radiation? How do you take care of thermal power? Power is only solar, right? So if our, let's say, NVIDIA GPUs take so much kilowatts, you need to put really big solar panels. So you have to design a system that really works. And finally, I would say, depending on where you put these data centers in space, space debris is a challenge. You can't really fix things on the fly. If something doesn't work, you need to have redundancy, and that's a big challenge. And I would also love to see, when you start deploying big and huge and massive data centers in space, what happens. One of the companies is called StarCloud. There, and then there are other companies as well. The size of their data center is 4 kilometer by 4 kilometer. So 16 square kilometer is the size of a data center, because most of it is taken by the solar panels, and that's what they need to capture the power. Not impossible, and I think we already know humans have built International Space Station. Chinese have built their own space station. These are massive ones. So solving these problems will are getting us there. And these are all solvable problems. I just want to see if the math would work in terms of business case and at what price point this is delivered.
Yeah, that's unbelievable, interesting. Space is capital extensive, technical, and slow in procurement cycles, obviously. Execution pressure must be real. Right now, what feels like the hardest part of running and scaling Little Place Labs?
Absolutely. For a company who's working in space, and space is also heavily funded directly or indirectly by government money, just means that you need to have a lot of patience, a lot and a lot of patience. When you come from a fintech world where you can build applications and you can launch in weeks, if not months, this is a big shift. The sales cycles are long, and then when you sell to government or the defense community, it tends to be, even longer. So this is kind of an entry barrier. VC is an entry barrier to operate in an industry. An entry barrier is not necessarily a bad thing because it kind of discourages your competitors. But At the same time, you need to have that outlook and that view that you can come over all these hurdles to get to the level where you can make that level of progress. Build, showcase technology, showcase your capabilities, scale ups, get bigger contracts. As a little story, Little Place Labs, as I mentioned earlier, was founded, from University of Oxford. I am based in the UK. My co-founder is a US based. He's based in Houston, Texas. And we operate the company in both the US and the UK. The US is where we have got more traction, right? And that's where we have been focusing a lot more as well in the last few years. The challenges are definitely around, because we are still a small company, and we rely on good partnerships to showcase our capabilities. So, having those relationships with satellite operators. With the whole industry, building satellites, launching and operating takes time. So we just have to work at the speed things get done. And the good thing is, in the last year, for some of the contracts that we won and when we worked on, especially in 2025 was a great year for us. We demonstrated how we can capture imagery on a satellite, process it, and deliver it to our customers with specific intelligence and insights that are looking at within 25 minutes. Typically, this is more like 6 to 8 hours, and if it is a priority one, if it is not priorities, it will be something like 12 hours. So our plan is to reduce that 25 minutes to under 15 minutes this year as we do a lot more deployments. So we have flown on 2 satellites up until now, and in the coming year, we are looking at 6 more missions. And I'm happy to say that one of the missions is on the International Space Station as well. So we will be deploying our technology on International Space Station with one of our partners. It's amazing. It's all about planning. It's all about making sure we can, sustain a team, keep building them, make sure we keep selling. As a startup, it's all about making sure there's a customer at the end. The customer finds value in your offering, and they're willing to pay for it, and there is enough cash flow in the company. In the initial days, it runs on different kind of investments, and we are coming to a point that we are starting to seeing more, starting with short-term contracts and long-term contracts with the customers.
Wow, wonderful. Thank you for these insights. Across industries, you see compute moving closer to the source of data. In your case, that source is literally in space. And
Correct.
from from your vantage point in space tech, what shifts matter most right now, but it's still underappreciated by the broader tech community?
I think space is a little different because when we compare that with other industries, you're right in saying that, compute has been also moving back to the location of source because let's say over a period of time, we have been clogging our internet with moving so much of data, something that could be avoided. A lot of data, like we say, is useless or never used. So let's be a little bit more reasonable around how we move data because, although it might be cheap on the ground, it's definitely not cheap when we move data between Earth and the satellites anywhere in space. So optimization of that data is definitely important. One of the things I would like to highlight is when we talk about space, especially in the initial years, it's getting better, but in the last few years, we treat space like it's 1985. We have a really less memory and compute, and we want to do a lot of compute on that. Like we want to run an AI and machine learning models on a really low-end device, which uses like 40, 50 watts of power and has only, let's say 2 gigabytes of RAM, which for a big machine is not a lot. So we start scaling down. How can we make our software really sleek, really efficient? And then use that concept to bring efficiency into the whole offering that we are building. And then once we have more compute, then we can compute more data. And trust me, there's a lot of data. And the data coming from space is petabytes of data. It's not even gigabytes, moving from gigabytes to terabytes and then to petabytes. It's in that range on a daily basis. And a lot of this is useless and never used. Simple things like you take imagery from satellites and it's cloudy, and the cloudy image, you can't really do much with that. So, a simple software that can identify clouds and imagery and remove them and not downlink them and discard them. It is a very, very simple way of showcasing how value can be added. And each satellite, probably data from each satellite, comes down to maybe $500,000 to a few $1 million cost in just getting the data down. So you can imagine if you can eliminate half the data because it's useless, you can eliminate half the cost in getting the data down. So it all ties back to efficiency and savings. So a lot of, generally on the ground, there's enough compute, there's enough memory. I know a lot of applications don't necessarily think of this as the first problem, but in space we start with the first problem as how much compute, how much memory, how much bandwidth do I have to move data around, and then you work with those constraints. Because we are thinking right now it's space, it's just probably satellites closer to us. But we are preparing for what will come as we are developing the moon base and the moon operations. And that I believe is going to be the next steps because moon will have the same challenges as, going beyond somewhat in deeper into space. You will need radiation hardened, good radiation and other elements of technology to support compute on the moon. And when you're building a moon base, of course, you need a lot of computers, you need a lot of compute. You cannot be sending every request back to Earth. So I was interested to see that SpaceX shifting their focus to also building the moon base first would definitely mean sooner building data centers on the moon. And trust me, I was surprised when I entered this. Is a lot more happening than people generally know. Moon is in discussions most of the time, highly explored. You know, the Americans and the Chinese are eyeing for the moon very soon. The Artemis 2 is going to be launched very soon as well, and probably in a month's time. Humans will have a permanent base, as they call, on the moon, a permanent human presence on the moon very, very soon. So uh, I I definitely bet on the space industry and the aspects of technology, the capabilities that are required will keep everyone busy for the next 1, 2, 3, 4 decades and even beyond. I can't even think how it will look by 2 decades or more because things would have grown by then so much. But just a view of in 1 or 2 decades, I think there is enough interest, there's enough capital, and there is enough geopolitical need to keep this area really busy.
Yeah. I mean, it's far away, moon. You get speed of light. You get your data in maybe a second or something like this. You have a second latency, no, or something. Then you have
I
to
think it's a few
be.
seconds, if I'm not wrong, was 6, 7 seconds. So it's enough that you can't have a real conversation like we are having right now. I mean, we take for granted at times, right? We can talk to anyone on Earth, and the latency we can work with, right? It's few tens of milliseconds of latency, maybe a few hundred. When it starts to getting few hundred milliseconds of latency, we start seeing that. But it's not going to be that on the.
So it's so cool. You said in our prequel that all these topics are not just relevant now, but over a longer horizon, obviously. Looking
Mhm.
ahead 12 to 18 months, what does success realistically look like for Little Place Labs?
Yeah. Uh, as the year ends, we do our uh, retrospective of how the year went, and we also kind of have an outlook of what the next couple of years would look like. We are looking to have our technology deployed on 55 plus satellites in the next 3 years. So what this would do is get us more coverage and revisit from satellites. Essentially, what I mean is that right now we have assets on 2 satellites. One of them is quite active, but that one satellite doesn't really pass an area of interest as frequently as a customer would want as the need arises. So what the customer wants is, yes, you can get us information from space in that 7 minutes, 15 minutes time frame, but you can only get me once a week or once in 15 days, and that's not good enough. The customer requirements is that, hey, I need this information quickly, but you need to give me like 4 times a day or 6 times a day. So the only way we can scale that up is by deploying our software pack and associated tasking technology on several satellites. And we have to sit on several satellites. And that's what we are currently working on to expand into several satellites. First of all, we want to come to a revisit rate where we can service a customer request on in a specific location, once every 3 days, then once every 2 days, then once every one day, and then multiple times a day. And that's where, customer will find a lot of value. And I think that's the focus for us. But at the same time, we're also exploring the increased demand of compute in space. The demand for compute in space as the infrastructure builds up is going to increase. So, looking at opportunities of how to offer to customers this compute in space demand for whatever use case they want to use, we should be able to service that. And this comes from the concept of, let's say, decentralized compute, which is making sure that, hey, there's compute out there in the satellites. How can we offer that in a simplest possible manner to the customers? And I think as we go along, we are waiting to see and get our hands on to some of these compute platforms in space. And when we use it, when we test it, we can build more products and offerings for the customers.
Amazing. I love it. Awesome. Okay, back to, I mean, talking about you, what habit or principle made the biggest difference for you in your life? As what a habit or principle made the biggest difference for you as an entrepreneur, as a founder? You're very patient, as you say, because you need a lot of patience in your business.
Yeah.
What makes you?
I would say, if I look back, even before I was an entrepreneur, I would say, you know, being proactive, trying to go out there and take small risks, understand how to take risks, and then subsequently take bigger risks as well was was something I was able to do. I wasn't I wouldn't I started this company when I was 40 years old. I did not have the risk appetite to do that earlier. But increasingly, when I understood that one can live without salary and have a more humble life, live below your means, then it's completely possible to pursue some of those goals and aspirations that you want. And I think and that still works because me and my wife and our son, uh, we're still backpackers in one way. We just need a small backpack and we can go anywhere, we can live anywhere. And that attitude really means that what we really want from life is experiences and not many things, and things tie you down. So those things really help us for us to take these kind of risks. And let's put it this way: when I joined Oxford, I was said, all right, let's go, let's try starting a company. By the end of this, I would have an MBA from Oxford. I'm not going to go hungry. I can just have a humble lifestyle. I could probably try something and maybe it doesn't work. That's all right. I'll get a job. But the fact that I haven't built a lifestyle that required a lot of cash flow. It was not an expensive lifestyle I had. It was always about a backpacker and experiences. And I think in a way we still are. So that probably really helps us, you know, build connections with people as well as we go along. I had a really great relationship I still have a great relationship with my co-founder. He was the first person I met when we started the executive MBA program on day zero. We met and then it just worked out for us. And then, even beyond, we live in different continents and we meet multiple times a year. But there's no hesitation, there's no issue if we are not around, and there's enough trust because we know that we can go through the downs of this journey together, and ups is not going to be a problem. So it's going to be a roller coaster, and we are here in this journey, whether it is going on a high side or the low side. At the end, we will come out successful. We would learn one way or the other.
Yeah, that's beautiful, and bravo for all this journey that you're taking in a very different way than everybody. If you could advise your earlier self before founding Little Place Lab, what would you say?
Before funding, I think I did.
Or at any time, yes,
Yeah,
but
yeah.
your
I
earlier
mean,
self.
yes, I know the answer. And I tell this to everyone. Before Oxford, before coming there, I realized I was not dreaming big enough. And I tell everyone, leave apart everything. It's an expensive program and a lot of amazing people. But it showed me how to dream big. And I wasn't dreaming big. I was playing conservative. I was just being risk averse because maybe that's how where I come from, where the family taught us, where the friends around us live in the same thing. But I met, I interacted, I felt, I got along with people who dared to dream big. And then if you don't dream big, you will never go and pursue those goals. So my nice advice and is whenever I spot somebody not dreaming big, I always give them a nudge and say, hey, why can't you dream big and try to do this? You can do this. There are a lot of people who do this. I just need to get them introduced to the fact that dreaming big is required. And then, of course, working on it in one way or the other will work. Because a lot of people have that desire to work, but they're not able to visualize what a big dream for them would look like. And I think that really worked for me.
Yeah, yeah, beautiful. I mean, you're on the way to a big, big dream. You're in the stars. You're in the sky. That's beautiful. Thank you so much for joining. Very strong insight into your journey and your industry and the work you're doing at Little Place Lab. This is amazing. Thank you so much for taking the
No,
time.
thank you, Laurent, for inviting me, for listening to me. I think it's a great program that you're doing, and I heard some other podcasts as well. So keep doing the great work, and all these stories from amazing people that the world needs to know. You never know where you end up in inspiring somebody or changing somebody's
Exactly.
life. And good luck to you, and all the best.
Thank you so much. Where can people find you, learn about your work, or get in touch with you?
Sure. If you just reach out to me on LinkedIn, that's where I tend to be really, really active. Or you just go to easily spot LinkedIn, you can go to gaurav.uk. That's gaurav.uk, and then you should be able to find me.
Wonderful. Thank you so much. And that's it for today's episode of the AI Interconnect. And if you enjoyed, share it with someone who's building the future, or better yet, someone who should be. And until next time, stay curious, stay creative, and keep building. Thank you, Gaurav.
Thank you.
Bye bye. We'll do it again.